Alright, today's lesson we're going to continue with our angles in different locations, and we're going to relate this to our three trig ratios, our sine, cos, and tan. So what we're going to start with is we're going to look at, see how Pythagorean Theorem relates to different coordinates and different angles. So we know from before our regular Pythagorean Theorem formula, a squared plus b squared equals c squared. Typically what we're going to do is we're going to relabel these and use x, y, and r when we're dealing with angles, because if I told you, let me just draw a little angle here, if I told you we have the coordinate of 3 over and 4 up, and if we were to draw that reference angle, we can see that our base of our triangle would be 3, our side would be 4, and you can see that that coordinate would actually be 3, 4, which is our x coordinate and y coordinate. So that's why we use x and y instead of a and b, because it relates to our coordinates a little bit better. And the reason why we use r is we actually think of this as being the radius of a circle. So if we actually were to relocate this reference angle somewhere else, but using the same measurements, in this case would be -3, -4, but our radius would still be the same in terms of that angle. And we'll get more into that into Math 30, but for now, we just typically use x, y, and r. So if we drew our triangle where it looked like x, y, and r, using Pythagorean theorem, you'd have x squared plus y squared equals r squared. So let's do a couple of practice questions. So for this first one, we got -5, 12. So if we went -5 over and 12 up, we'd have our reference triangle would look like that. So using Pythagorean theorem, our r would be -5 squared. Make sure you put it in brackets on your calculator. If you type in -5 squared without brackets, you'll actually get the wrong answer. It'll give you -25, where -5 times -5 is +25. So in this case, we'd have 25 plus 144, which would give us square root of 169, which will simplify to 13. So in this case, our r would be 13 for that reference angle. If we try another one where we have -2, -6, and we solve for r in this case, we'd have -2 squared plus -6 squared, which will give us 4 plus 36, which is root 40. And we want to keep these as exact as possible, so we usually just leave it as root 40, or if we really wanted to, we could simplify the root to make it 2 root 10. So either 2 root 10 or root 40 is our best, most exact answer for these kind of questions. So dealing with the angles, pretty straightforward, just using Pythagorean theorem, but because it's a 90-degree angle triangle, we also can solve for our sine, cos, or tan. We can use our SOHCAHTOA rules to figure out those ratios. And instead of using opposite over hypotenuse, you can see here if our angle is down here, our sine would be opposite, which is our y side, divided by our hypotenuse, which would be r. Our cosine would be x over r, and tan would be y over x. So sometimes these formulas help a little bit in terms of helping you figure out your trig ratios, but you can just use SOHCAHTOA too. It works totally fine. So let's try this one. We got 15 over and 8 up. So our angle would look something like that. So we can use our Pythagorean theorem rule to figure out what the radius would be. So we'd have 15 squared plus 8 squared, square root that, and we get 15 squared is 225. And 8 squared is 64. We add those together, we get 289. And square root of 29 is exactly 17. So our radius would be 17 in this case. So now we can actually do our SOHCAHTOA. So our sine would be opposite over adjacent, or opposite over hypotenuse, or in this case the y coordinate over our r. So we'd have 8 over 17. Our cosine would be x over r, so that's 15 over 17. And our tan would be 8 over 15. So you can just use our formulas, or just go back to your triangle and do opposite over adjacent. Those types of things will work just as well. So let's look at now what happens when we get specific angles. So if I was to give you the exact same thing, if we say our coordinate is 1 over and root 3 up, so root 3 is like 1.7 or something like that. So we have a coordinate that's 1 and root 3. If we were to actually draw our triangle like this, and if we do our Pythagorean theorems, we got 1 over root 3 up. Root 3 squared is 3, plus 1 would be 4, so square root of 4 is 2. So we've got our R value of 2. So we did root 3 squared plus 1 squared, which would be square root of 4, which gives us 2. And the first bullet I missed, but it's asking us to show us that the angle is 60 degrees. So we could do tan of the angle equals root 3 over 1, opposite over adjacent. So if we go second tan of root 3 on our calculator, that gives us 60 degrees. So we know our reference angle is 60 degrees for this one. So now we can calculate our sine, cos, and tan. We already know the tan one, we just did it, but let's do the rest. So sine of 60 would be root 3 over 2. Cosine of 60 would be 1 over 2. And our tan of 60 is root 3 over 1, or we can just write it as root 3. Okay, so those are our 3 basic trig ratios for 60 degrees. So what we're going to look at next is we're going to do the same thing, but we're going to look at what happens when it's at 120. So if we're to draw 120 degrees, that would be the same thing as 60 degrees as a reference angle. And if our reference angle is the same, that means we actually have the exact same triangle, except now we're going backwards, so it would be -1, but we'd still have root 3 up and 2 over. So in this case, we have a 60 degree reference angle, so now our sine, cos, and tan, if we use our triangle that I just drew, so we can go sine of 120, so that's opposite over hypotenuse, so that's root 3 over 2. If we do cosine of 120, we get -1 over 2, and our tan at 120 would be root 3 over -1, and we could simplify that to just be negative root 3. So it's asking, how do these compare to the 60? So if we kind of go back and look at the 60 answers that we had, you can see we have root 3 over 2, 1/2, and root 3. You can see these ones are exactly the same thing. The only difference is we're getting a negative on the cosine and a negative on the tangent because our x coordinate was negative. So anyone that have the x's give us a negative value. But other than that, the answers are actually all exactly the same. So let's try another one now. That's 240. So if we go 240, that's going to be down here somewhere. Our reference angle is still going to be 60. So we actually have -1 again. We still have root 3 and 2, but now in this case the 1 and the 3 are both negatives. So our reference angle is still 60, and if we do our sine, cos, and tan again, so sine of 240 is negative root 3 over 2. Cosine of 240 will be -1 over 2, and tan of 240 is negative root 3 over -1, which we could simplify to just positive root 3. So once again, it's asking how these compare. So if we go back to the previous page, same answers. You can see the only thing that changes really is where the negatives are located. So in our first one, we had no negatives. The second one, we had 2 negatives, but the sign was positive. This one, we can see the sine and cosine are negative, but now the tan is positive. And if we do this one more time for 300 degrees, so 300 is over here somewhere, we still have a 60 degree reference angle, and we would have 1 over and root 3 down this time. So if we do our sine, cos, and tan one more time, so sine of 300 will be negative root 3 over 2, cosine of 300 will be 1/2, and tan of 300 will be negative root 3 over 1, or just negative root 3. So once again, if we compare these ones now, we can see sort of what's going on. So let's go back to the first one. So there's our first diagram. So when we were in quadrant 1, you can see all of these are positive. So we had positive sine, positive cosine, positive tangent. When we were in quadrant 2, you can see our sine was positive. The other two were negative. Quadrant 3, we have a tan being positive, the sine and cosine are negative. And in quadrant 4, the cosine is positive and the other two are negative. Other than that, all of our angles are exactly the same. So what that means is we don't actually have to do sine, cos, and tan for every possible quadrant. We basically just want to deal with the reference angle. And once you know the reference angle, you know the answers are all going to be the same. So we just did 60 degrees, which would be this one here. So I'll just rewrite these. So sine of 60 was root 3 over 2. Cosine of 60 was 1/2. and tan of 60 was root 3. We could do the exact same thing for 30 degrees. You can see the triangle of 30 and 60 is the same triangle, just reversed. So what ends up happening is we get reversed answers. So sine of 30 is a half. Cosine of 30 is root 3 over 2. So you can see those are just traded. And tan of 30 ends up being 1 over root 3. So we get a reciprocal of the other one. And then if we do this for 45 degree triangle, we have both sides being the same. So both sides are 1. Our hypotenuse would be root 2. So if we do sine 45, we have 1 over root 2. Cosine 45 is 1 over root 2, and tan 45 is 1 over 1, which would just be 1. So those are our special angles, and these are on your formula sheet, but it's good to sort of get used to using them. And you might also see we could rationalize these to not have the root on the bottom. So if we times top and bottom by root 2, we'd actually get root 2 over 2. So that's another way of writing that one. And you might even see this one as root 3 over 3. Just so you're aware that it could be in a different form. So what do these triangles mean? Well, if we have a reference angle of 30, 45, or 60, we know what the sine, cos, and tan are going to be. We don't need to try to calculate them. So the only thing that's different is which quadrant is which in terms of whether they're positive or negative. So we use what we call the cast rule, and what that means is in this quadrant 1, A stands for all things are positive. The S stands for only the sine is positive. Here the tan is positive, and then in our quadrant 4 the C is positive. So we call it the cast rule, but we start in the bottom corner and go CAST around in that direction. So sine is positive, this one our tan is positive, here we have cosine being positive, and here we have all of them are positive. Okay, so what that means is no matter where we are, we can actually solve these things pretty easily. So let's do a quick trial one. So if I gave you the tangent of some angle, let's do tan of 225, and I want to know what that is, all we basically have to do is sketch where 225 is. So 225 would be somewhere in there. Figure out our reference angle. So 225 minus 180 would give us 45. So we know it's 45 reference angle. If we look back at our special triangles, tan of 45 is 1, so we know our answer has to be 1. And we're in the tan quadrant. We know that tan is positive there, so we're done. Our answer is positive 1. Okay. If we were to do a different one, let's try sine of 210. So now we know we're in quadrant 3 again. Okay, but 210 will be a little bit smaller. So something like that. Our reference angle we know would be 30 degrees. So when we look at our special triangle, sine of 30 is a half. So we know our answer is a half. Then we just got to use our cast rule to help us figure out whether it's positive or negative. So in this quadrant, only tan is positive, so that means our sine would be negative. So negative 1/2 should be our correct answer. Now let's do one more for cosine. So let's suppose I give you cosine of 150. So we know it would be up in this quadrant. It's still 30 degrees as our reference angle. When we look at 30 degrees for cosine, we get root 3 over 2. And because we're in the S quadrant, we know that that would be negative as well. So negative root 3 over 2 would be our final answer. So the process is going to be the same. You're going to do reference angles, figure out what the answer is, and then determine whether they're positive or negative using the cast rule. So let's just do a few more practice ones. So this one is just asking whether they're positive or negative. So all you have to do for that is determine which quadrant it's in and check it out. So sine of 340 would be down here. That's our C quadrant, so that one would be negative. Tan of 227, that's somewhere in there. That one will be positive. 88 is in our first quadrant. Everything's positive. Cos 235 would be somewhere in there. That's our T quadrant, so that one's negative. 308 will be positive, and 123 is up in there somewhere. That one will be negative. So cast rule, that's all it's used for, is to help you determine positive or negative. So let's do a few more. These are like the ones we did earlier. Let's see if we can actually figure out the exact ratio. So 240, sine of 240 would be 180 plus 60. So we know we have a reference angle of 60. Sine of 60 is root 3 over 2. If you look at your special angle list, and because we're in the t quadrant, that means sine would be negative. So negative root 3 over 2 should be our correct answer for that one. Okay, let's try the next one. Tan of 150, so that's somewhere up there. That'll give us a reference angle of 30. Tangent of 30 is 1 over root 3. And in that quadrant, that's our S quadrant, so that one should be negative as well. Okay, let's try a couple more. So sine of 225. So 225 would give us an angle of 45 degrees. So our sine of 45 is 1 over root 2. Because it's in the t quadrant, that one's also negative. Okay, cosine of 135. So 135 is in quadrant 2. Reference angle will be 45. Cosine is also 1 over root 2. And in that quadrant 2, cosine is also negative, so we get the exact same answer. And you can always try these on your calculator. You can type in cosine of 135, and it'll give you negative 0.707, which isn't matching this exactly, but if you went 1 divided by root 2, you would see that it's the exact same answer. Okay, let's do the last two. So tan of 300 would give us a 60 degree reference angle. Tan of 60 is root 3, and because it's in that quadrant, it'd be negative. And our last one, 330 would be reference angle of 30. Cosine of 30 is root 3 over 2. And we're in the C quadrant, so that one will be positive. And that's it for this stuff. Tomorrow we'll continue with this. We'll look at a few other special angles, but that's pretty much the main idea for this topic.